Alright guys, so at this point you should have already had all these functions graphed. You should have used your calculator to double check your work to make sure that you have the correct parent function. So I'm assuming that you do. So I'm just going to go ahead and skip all the way to number 9. Okay? Alright, number 9. Did anyone get the graph without using the calculator? Alright. I know some of you guys were able to discover how to do it in the calculator. Awesome. Okay? But I want to make sure that you know how to do this by hand, because in order for you to really understand this function, you need to be able to graph it by hand. And in order for you to graph it by hand, you need to know the definition of the function. Okay? So this is where we're going to pick it up, at the greatest integer function. Okay? First of all, I saw that some of you guys, I don't know if in this class, went into the calculator and typed the brackets and then the x and then another bracket and then you hit graph and then you got an error. And if you did that, awesome, fantastic. That's what I would have first tried, okay? Then you may be asking yourself, well, why didn't this work? And the reason for that is kind of my fault, okay? As I was typing these notes, I couldn't find the actual symbol for it. So that's not the actual symbol for it, okay? So here's what the actual symbol looks like. So I want you to write it. So in this case, it's y equals. It still looks like that, but you actually have to add a little bar here. Okay? It's like a double bar bracket. At this point, you're going to start, some of you guys are already starting to look at your calculator to see where it's at, and then I'm going to give you bad news because it's not in there. There's not a symbol in there, okay? I'm going to show you how to do this in the calculator here in just a second, but first let's talk about it, how to do this by hand. And in order to do this by hand, like I said, we need to know the definition. So here's the definition for the greatest integer function. Okay? You ready? It is the greatest integer, shocker, the greatest integer, here you go, that is less than or equal to x. The greatest integer that is less than or equal to x. Alright, let's pause and think about this for a moment. Okay? In order for you to truly understand this definition, there is one major word here. What is it? Integer, right? That's the big word that you need to know what it means. I know that you know what greater means, right? Greatest. Do you know what integer is? What is an integer? So let's come up with a definition together as a class. Who remembers what an integer is? What is it? Or give me an example. Okay? Yes? A whole number. A whole number will be an integer. I agree. What else will be an integer? Yes? A negative number. So now we've got whole numbers that are positive and negative. I'm there with you. We're missing something, and it's huge. Zero. Yes. Integers, now together as a class we came up with the definitions. Integer is the set of all whole numbers, positive and negative, including zero. So if you didn't know that, you need to write that down. Integers is the set of all whole numbers, positive and negative, including zero. Cool? Will the number negative 4 over 2 be an integer? Why? It's a fraction. Negative 4 over 2 is a fraction, but it is negative 2. That is a whole number, right? So just because you see a fraction, don't automatically think that it's not an integer, right? Good. Alright, now that we know what an integer is, now we're going to actually apply this definition. Okay? When you first learn to graph, typically the first step they tell you to do is to create a table, plot some points for x, and find out what their outputs would be, right? Well, prior to knowing the definition, do you see how that would have been difficult to do? Right? But now that we know the definition, let's apply it. Let's start with typically everyone starts at 0, right? If I plug in 0, using the definition, what is the greatest integer that is less than or equal to 0? Awesome. So I'm going to plot that point. Agreed? I'm going to plot the point number 1. What is the greatest integer that is less than or equal to 1? What about 2? Are we getting a pattern? What about negative 1? Do you guys agree? Are you guys all with me as far as this goes? At this point, you must be like, well, that can't be possible, Mr. Carrion. That's linear, right? That would look exactly like y equals x, so what's so different about this one? And here's where I would pause you and say, well, we haven't really considered decimals, right? So let's talk about that, because there are numbers in between 0 and 1, and 1 and 2, etc., right? So let's talk about those. Let's start at 0, between 0 and 1. Pick a number. Between 0 and 1. 0.75. Great. If you plug in 0.75 to the definition, 0.75, what is the greatest integer that is less than or equal to 0.75? 0. Right? Because 1 would be what? 5, you're going to plot the 0.0, right? What about a 0.9? 0. 0.999999999. 1. 1, 1. So what happens? Between 0 all the way up to 1, and then you go up here, right? Guess what? You need to put an open circle right here. And then you plug in 1, right? And then you put 1.1 and you get what? Do you get 1 or 2? 1. And then you continue all the way till you get to 2, and then you're up here, right? You guys see the pattern? Your calculator does not show you the open circles. They are necessary. Okay? Why must it be necessary that you put that open circle? Anyone? Michael, what you got? They do, but I want you to think about this is a function, right? It's not a part of it. If it was, what would happen? It wouldn't be a function. Why not? You would fail the vertical line test, because then you would be touching at 2 points. Do you guys see why it's so important to have that open circle there? We're good? All right. Now, I understand that you're getting the pattern, right? And from this pattern, you can go on the negative direction, right? But I want to take some time for you to literally think about plugging in negatives, because sometimes it gets confusing, okay? So let's pick a number between negative 1 and negative 2. Somebody. Negative 1.5. What is the greatest integer that is less than or equal to negative 1.5? Negative 2, right? Less than or equal to. So at 1.5, you're over here, right? You guys see that? So that's why it would look like that. And does that follow the pattern that we've had so far? Okay? Be very careful when dealing with the negatives in here. Okay? Questions about the greatest integer function. This will appear on your test. Okay? Alright. Next thing I want to talk to you about is flip the page. And let's talk about the function of sine and cosine. Okay? The whole concept of sine and cosine should not be something totally new to you. You saw or you learned about sine and cosine when? Geometry. What do you remember about sine and cosine in geometry? What did you learn about them? Parker? SOHCAHTOA. Right? Sine is what? Opposite over hypotenuse. And cosine is? Alright, so sometimes I feel like a lot of us get stuck in this whole SOHCAHTOA term, but then when someone asks you what is sine, you can't really explain it. What is sine though? And what is cosine? What does it mean to be opposite over hypotenuse? What does it mean to be adjacent over hypotenuse? It looks like a fraction, right? What's another word for a fraction? It's a ratio. Don't forget that. Sine and cosines are ratios comparing the sides of a triangle, of a right triangle specifically. Okay? Alright. However, now we're going to have to kind of look at it from a perspective of a function. Okay? And you're going to see on the next unit how that triangle ties into the function. Okay? But we'll get there. For today, I asked you to use your calculator. Okay? And what did you guys notice about sine and cosine? They look almost exactly the same. With what difference? Yes.
For sine, it crosses through the origin, and then for cosine, it doesn't come to the origin, but it crosses through the y.
Very good, and that's very important, guys. For sine, you will have an x-intercept at 0, 0. And for cosine, you would have a y-intercept at what? 1, 0. Okay, so here's what I need you to do. Let's plot those points for the moment, right? This will be the point 1, okay? And I want you to go down here and put negative 1. I want you to do the same thing for both. 1, negative 1. Okay? Here's what happens. On sine, you're going on this direction, and then you get as far up as 1, and then you turn, and then you go down, and then you go as far as down as negative 1, and then you go up, and this repeats. Okay? With cosine, you actually start up here, right? And then you go down, and you go to negative 1, and then you go back up, etc. You should have something similar to what I have here. If you didn't have the whole negative 1 and 1 concept in there, please go ahead and add it. If your function of sine was not going through the origin, make sure you change it. If your cosine was not going above the origin, make sure you change it. Okay? As far as sine and cosine, I'm going to stop there for now. Okay? Questions about sine and cosine? We're good? Alright. Now, before we move on to this section of symmetry, there's one more concept that I want to talk about, and it came up on our conversation earlier of what a function was. And it was the concept of domain and range. Okay? I need to make sure that you remember how to find domain and range. Okay? I'm sure you do, but then I'm going to ask you for a very specific way of writing domain and range as far as my class goes. So I'm going to show you. Okay? So I'm going to do 2 examples with you. Let's flip the page back and let's go to problem number 4. Okay? Problem number 4, if you grab this and you plot some points, you get something like that as a parent function. Correct? Alright. Just by looking at that function and knowing, using your knowledge of what you know about domain, can anyone tell me what the domain is? Domain, is that inputs or outputs? Inputs, is that X or Y? X. So, can I put a negative X in there? No. Can I put 0 in there? Yes. Can I put a positive number? So then what's your domain? 0 to infinity. Okay? So verbally, I know that you know the domain. Now I'm going to show you how to write it. There's 2 ways that I'm going to ask you to do this for my class. Okay? The first way is known as the interval notation. Interval notation. So for the domain, you ready? Alright, interval notation is what I think most of you guys are familiar with. With interval notation, you have a starting point, and then you have an ending point. What is the very first value that you can use in your domain? So you're going to write 0. What is the very last value, or concept in this case? Infinity. So you're going to put a comma in infinity. Now, I think you're getting the idea where I'm going with this. You need parentheses or you need brackets. Is that coming back to you? When would you use parentheses? Do you guys remember? Either when it's infinity or when it's not included, right? So when you cannot actually reach that point. And you would use brackets when you can actually include that as part of our domain. So brackets or parentheses? Parentheses. Very good. Now, the other notation is known as set notation. Okay? And here's how you write domain. Okay? As you progress in this class, you're going to notice that I do this on purpose, and I don't know if other campuses do it, but I use a lot of symbols because I'm very lazy and I hate to write words. And math has, just so you know, there's like an actual course that you can take to learn all the symbols in math in college. Because we're lazy again. Instead of writing things, we write symbols. Okay? So you ready? The symbol for the word the set is the following. This symbol right here means the set. So if you want to write that down, that means the set. So we're looking for a set. The set of what? Okay, well, we typically write it this way, okay? And you should be familiar with this symbol. What does that mean? All real numbers. Well, let's talk about it. Is it true for our purpose on this problem? Is it really all real numbers? For our domain? It's not, right? It's only part of them, right? Very specifically from 0 to infinity. So there's a way that you're going to be able to tell me that. You have to tell me, and this is the symbol that you're going to use. This means such that. So if you want to write that down, that means such that. Well, what's your speculation in this? Such that what? What has to be true? What is the domain? This is where you're answering. What is the domain? 0 to infinity. We're going to use inequalities for this. You guys remember using inequalities? So how could you say from 0 to infinity? 0 is less than or equal to x? No. X is greater than or equal to what? X is greater than or equal to 0. Close your set. And that's it. These two things are saying the exact same thing. One of them is known as interval notation. The other one is known as set notation. On your test, I will be very specific on which one I want. If I ask you for interval and you give me set, I'm going to count it wrong. If I ask you for set and you give me interval, I'm going to count it wrong. On the quiz, I'll give you a break. I'll write a note like, okay, it's the other one. Okay, don't make the same mistake on the test. Cool? Let's do one more to make sure we understand it. Cool? Let's look at number 8. Before I go there, do I have to go through the range, or you guys can do the range on both? Right? Are we good? All right. Number 8. The rational function, you should have something that looks like this. That signifies that I have asymptotes. And it looks something like that. Agreed? All right. If you don't have that, correct it. Anyone, just by looking at it, can you tell me what the domain is? Just verbally. Everything except what? Right? Because I can put any negative number on the denominator, right? And I can put any positive number, but I can't put 0. Okay? Does anyone want to try to do this in interval notation? How would you do this in interval? So there's always a start, negative infinity, and I'm going all the way to what? Am I going to infinity? I'm going to 0. And I have to stop at 0 because there's something happening there, right? And then what happens after that? Then you go from where to where? From 0 to infinity. Alright. We need to make sure we have brackets and parentheses in here. Okay? Parentheses belong where? With the infinities. Right? Do I actually include them as well with the zeros, or do I use brackets for the zeros? Parentheses, because can you actually reach 0? You cannot. Now, there's something that I'm missing in this statement. Does anyone know what it is? Jay. There's a U that should be in between here. U means union. That's the symbol for union. That means that you have this interval from here to here, and then you pick it up from here to here. Okay? It seems kind of silly that you're stopping at 0 and starting back up at 0, but you have to do that because that allows me to know that there's an asymptote there. Because if you just put negative infinity to infinity, you're telling me that you can actually plug 0 in there, and that's not true. Correct? All right. How would we write this in set notation? Little bracket, right? All real numbers. Such that. Now I'm going to flip things up for you a little bit. If I put everything that I can include, it's going to be a lot of writing, right? Kind of lazy. How about instead of including everything that I can, I write what I can't? What can't I include? So what would I say? X cannot equal 0. And close your set. And that will be perfectly acceptable. Yes?
Is it always going to be all real numbers?
Yes. Questions about the difference between set and interval notations? Are we good? All right. On your homework, you're going to have the chance to practice that, okay? All right, so let's go ahead and go flip the page, and we're halfway through our notes, okay? So let's go back to this concept of symmetry. All right. I'm taking you back once again to geometry. Yay. Symmetry. What do you remember about symmetry? What is symmetry as far as geometry goes? In your own words, explain it to me. Use your hands. Typically, that's what everyone does. Right? This is all it means. In order for something to be symmetric, even when you were back in elementary, the first thing your teacher was is typically they drew a butterfly. And then they drew a line down the middle of that butterfly. And they were like, can you fold this paper? And then they'll be like, yes, I can do that. And then you fold it, and then you see, oh, it matches on both sides. That's symmetric, right? Vertically. And then the teacher would ask you to do a line horizontally, and then you would do it, and then it wouldn't work. And that would be your example of that's not symmetric, right? We're going to go as far back as that to help us now with functions. We're going to use the concept of symmetry to help us figure out whether a function is even, odd, or neither. And you may be asking yourself, well, why do I care if something is even, odd, or neither? I don't really care, right? Now, I'm going to ask you to hold on to that question. At the moment, it might seem kind of pointless why we need to know whether something is even, odd, or neither. But in an upcoming lesson, you're going to understand why it's necessary to know that. Okay? All right, so for the moment, just take my word for it. We're going to use symmetry. You ready? And I already wrote it down for you. An even function is symmetric with respect to the y-axis. So if you look at example 14, your y-axis is right here. If you fold it along that line, would it be symmetric? Guess what? This is even. 14 part 2. I messed up on the typing. If you fold it along y-axis, would that be symmetric? Is it even? Question 15. Would that work? No. So the only one that was even was 14. Cool? An odd function is symmetric to the origin. Wait a second. What? To the origin? What is the origin? It's an actual point. How can you be symmetric to a point? How is that possible? Okay? It's a little more difficult to understand it. So I have a trick for it. You can actually rotate your paper 180 degrees. If the graph doesn't change, if it looks exactly the same as before your rotation, it's odd. Take a look at this 14. You ready? I'm going to do my best to rotate here on the camera. Look at the way it looks. If I rotate 180 degrees, does it look exactly the same as before I turned it? No. Look at this middle one. You ready? Does it look exactly the same as before I turned it 180 degrees? Yes, it does. What about the last one? No. Because this middle one did, this is odd. Notice how 15 didn't fit with even or odd? Guess what? It's neither. If you struggle with the whole rotation, if that's not your thing, there's an alternate way that you can do this, and this is the actual way that I use. You ready? I actually do a double reflection. Here's how it works. First, I do the test for even. So I'm going to, let's say I use this part right here in quadrant 1. If I was to reflect it over the y-axis, you would get something like this, right? Agreed? And then I reflect that part over x. Would it match down here? Look at this part. If I reflect, and then I reflect again, would it match? If you do that and the entire graph does that, then that's the other way that you can use symmetry in respect to the origin. Okay? Questions about symmetry using the graphs? Great. Last one, and I'll leave you guys alone because you guys are falling asleep. Okay? Ready? Unfortunately for you, since that's so easy to tell graphically, in your test I will probably not put graphically. I will do it algebraically. Okay? But it actually is not that terrible. It's relatively simple. There's only 4 steps to it. Okay? And I actually gave you the steps. First of all, you're going to be given a function like the 3 examples that I gave you here. And all I'm going to say is determine whether the function is even, odd, or neither. These are the steps that you're going to follow. Step number 1. Substitute negative x in the equation. Everywhere you see an x, put a negative x. Here's what I mean by that. That's what I'm asking you to do. What does that mean? Okay? If you're having difficulties thinking, how about if I give you that, what would you do? G of 2. You would plug in a 2 for every read. Well, you're doing the same thing, but I want you to put a negative x. Now, here's a strategy that I use to make sure that you don't make an algebraic mistake. Before actually putting the negative x, I rewrite the same statement that I have, but instead of using x's, I use parentheses. Here's what I mean. X cubed minus x. Is that the same thing? Now that you have your parentheses, I go ahead and input the negative x. Cool? Step number 2, simplify. What is negative x times negative x? Times negative x. So it becomes negative x to the 3rd power. Agreed? Minus negative x becomes plus x. Alright. I want to bring your attention to the original function, which was x to the 3rd minus x. So here's your original function. And I want to bring your attention to g of negative x. What do you notice? They're what? The signs are flipped. The signs of what? Every single term. Do you guys agree? Look at the very first term. It was positive, but now it's negative, positive. I want to go back to this number 3 and number 4. Check out. Here's what happens after you do the steps number 2. You got to check this one. If the equation simplifies to be the original, it's even. Did it simplify to be exactly like the original? Alright, so it's not even. If the equation simplifies to be opposite of the original. What I mean by opposite, I mean all terms changed signs. Oops, signs. Did all terms change signs? So this is odd. Okay? I'll do example number 3 with you, and then that's all I got for you. Step number 1, f of negative x equals 5 minus 3 parentheses. I'm going to input the negative x. Agreed? I'm going to simplify, and this becomes 5 plus 3x. So f of negative x is 5 plus 3x. Did it simplify to be the original function? So it's not even. Did it simplify to be the opposite? No, it did not. Why not? The 5 stayed positive. Because that 5 stayed positive, you cannot say that this is odd. Therefore, it's not even. It's not odd. It is neither. You can try example number 2 on your own. And this is the last thing I'm going to show you, because everyone gets confused with the instructions on this one. It says complete the graph to make it even and complete the graph to make it odd. I'm going to put evens in purple and I'm going to put odds in red. In order for a graph or a function graphically to be even, it has to be symmetric with respect to what? The y-axis. So here's what I mean by there you go. Now it's even, right? That's all I'm asking you to do. What if I want to make it odd? It needs to be symmetric with respect to the hope I'm right. Bam. Cosine test. Questions? Comments? Concerns? We're good? Alright, for homework, you will get the following worksheet. Notice that this worksheet is full of word problems. You are going to read the problem and you are going to tell me what type of function would apply to that. Quadratic, exponential, etc., etc., etc. Okay? 11 through 13, you're practicing even, odd, or neither. Even, odd, or neither. Even, odd, or neither. And 20 is all these graphs. You're practicing pretty much everything you learned today. What type of function is it? Domain or range? I would like for you to try both types of notation. So make sure you practice both types of notations with that and tell me whether they are even, odd, or neither. Cool? Alright, that's all I got for you today. The rest of the day you can use it to do your homework, and I'll pass it out here in just a second.